Welcome to Uma's classroom for math and science videos. In this video, today we will discuss the topic the law of constant composition or law of definite proportion, which is a part of laws of chemical combinations from high school chemistry and AP chemistry curriculum. There are certain rules followed by all atoms while combining to form a compound. And those rules are collectively known as laws of chemical combinations. They are namely the first one, law of conservation of mass, second one, law of constant composition or law of definite proportion, third one is law of multiple proportion, and the fourth one is law of reciprocal proportion. I already mentioned in this video we will learn about the law of constant composition or the law of definite proportion. The law of definite proportion or the law of constant composition was first proposed by Louis Proust. The law states that the elemental composition of a compound is always the same, and that means the elements always combine in the same proportion by mass with each other to form a compound. In another way, we can say that a chemical compound always contains the same elements combined together in the same proportion by mass. The law of definite proportion or the law of constant composition mainly applies to compounds because it refers to a constant or definite composition of elements within a compound. Here are few examples of law of constant composition. For example, pure water, regardless of its source, consists of 11% of hydrogen and 89% of oxygen by mass. This is the molecular formula of pure water. So, if we consider the total molecule is 100% by mass, and if we get the fraction contributed by hydrogen and the fraction of mass contributed by oxygen, then we will see 11% is coming from hydrogen and 89% is coming from oxygen. So, here the mass contribution by hydrogen atom is 2. Total mass of this water molecule is 18, and if I calculate the percentage, this is giving me the result that is approximately 11%. And so on the other hand, the mass contribution of oxygen, in that case, I can easily calculate by subtracting this amount from 100, which is 89%. So, if we take the ratio of hydrogen and oxygen by mass in water, we will see it is coming 11:89. Which is approximately 1:8. We know that 8 times 11 is 88, which is very close to this quantity, so it is approximately taken as 1:8. So it was actually the ratio of mass of hydrogen and the mass of oxygen. Similarly, carbon dioxide always contains carbon and oxygen in 3:8 ratio by mass. This law is often applied to groupings of elements in compounds. Hydrates are salts that have a certain amount of water as a part of their structure. Here is one example of magnesium sulfate heptahydrate. This hydrate always contains 126 gram of water for every 120 gram of MgSO4. Now, if we take the ratio of water with the magnesium sulfate and of course by mass. So, from the given information, the contribution of water molecule by mass is 126 is to the contribution of magnesium sulfate by mass is 120, and if we reduce this, we are getting this fraction. And regardless of the source of this compound, we will see always the proportion of water and magnesium sulfate by mass will remain as close as this ratio or exactly same. Here is one numerical problem which states that 1.37 gram of cupric oxide which was heated with hydrogen to yield 1.098 gram of copper. And for the second sample, this much of copper was dissolved in nitric acid to produce copper nitrate, which was then burned to produce 1.476 gram of cupric oxide. So here the main compound I would be dealing with is cupric oxide. Now the question is asking, does the result support the law of definite proportion? So we have to check the amount of copper and oxygen in both the cases. Then we have to take the ratio of their contribution by mass. So I am starting with the first sample, sample 1. Total amount of cupric oxide is given and that is 1.375 gram, which was heated with hydrogen to yield 1.098 gram of copper. So copper quantity is given 1.098 gram. Now let's find out the mass of oxygen, which is 1.375 minus 1.098 gram. If we do the subtraction, this is coming 0.277 gram. Now the next step is to get the ratio of copper and oxygen, of course by mass. This equals to, copper is this one, 1.098 is to 0.277. This is equals to 3.96 is to 1. we have another sample. Let's check for that one. Sample 2. For sample 2, copper oxide is 1.476 gram, and amount of copper is given here as 1.179 gram. So I can easily calculate the amount of mass by subtracting 1.476 minus 1.179. And this gives us a value 0.297 gram. Now let's check the ratio of copper and oxygen. Copper is this one, 1.179 is to 0.297 equals to, this is also 3.96 is to 1. So here we are getting copper oxide by two different reactions. But at the end we see the ratio of copper and oxygen by mass in both the cases, that is exactly equal to each other. So we can conclude the results are in support of law of definite proportion or the law of constant composition. We have another numerical problem here which states that 1 gram sample of a hydrate of a salt loses 0.361 gram of mass on heating. A 1.250 gram sample of the same hydrate loses 0.455 gram on heating. So here my compound is a salt hydrate or hydrated salt. For the first sample, for sample 1, the total mass of the sample is given as 1 gram, and it states that the salt loses 0.36 gram of mass on heating. That means the mass of water in this hydrated salt is 0.361 gram. Therefore, the mass of salt will be 1.000 minus 0.361 gram, which equals to 0.639 gram. Now, if we find out the ratio of salt and water, of course, by mass, we can see from the results, this is going to be 0.639 is to 0. This one 361 equals to 1.77 is to 1. We have another sample let's check for sample 2. The total mass of the sample is given as 1.250 gram, and it states that it loses 0.455 gram on heating. That means the mass of water equals 0.455 gram. Therefore, the mass of salt for this sample is going to be 1.250 minus 0.455 gram, which equals to 0.795 gram. Now let's check the ratio of salt and water for this particular sample. This is going to be 0.795 is to 0.455, which equals to 1.74 is to 1. Here is one correction. This is going to be is to. Now let's look at the ratios for both the samples, and the ratio of salt and water by mass for both these cases are approximately going to be equal to 1.7 is to 1. So here the chemical compound contains the same elements combined in the same proportion by mass is absolutely true, because we know that this rule is valid for group of elements also. According to the result, this experiment illustrates the law of definite proportion. Now, if we look at this, does this experiment illustrate the law of definite proportion? Of course it is. I hope my videos are helpful for you. So please continue watching math and science videos from Uma's classroom, and don't forget to subscribe, share, like and comment to get the update at the earliest. Here are some limitations of this law of constant composition or law of definite proportion. Firstly, the law is not true if the different isotopes of the element are involved in making a chemical compound. For example, hydrogen chloride. Chlorine can have two isotopes. The first one is 35 and the second one is with the mass number 37. So, if this isotope is used, in that case the ratio of hydrogen and chlorine by mass would be 1:35. Whereas instead of this isotope, if this one is in use, the ratio of hydrogen and chlorine by mass would be changing to 1:37. So here for the same compound, for the same elements, the ratios of the elements present by mass in the same compound is not same. And the law is not applicable when elements combine in the same ratio but different compounds are formed. For example, this is dimethyl ether, whereas this is ethyl alcohol. In both the compounds, the elements are carbon, hydrogen, oxygen. And if we calculate the total number of atoms, let's look at them. Here are 2 carbon atoms, here are also 2 carbon atoms. So it is going to be C2, H6 and O for both of them. And definitely if we check the ratio of carbon is to hydrogen is to oxygen by mass, it is coming like 24 is to 6 is to 16, or in a simplified or reduced version it is going to be 12 is to 3 is to 8. But in both the cases, the properties of this compound and the properties of this compound, they are absolutely different. This is ether, this is alcohol. So these types of compounds are known as isomers. And the law of constant composition does not hold good in these cases. And there exist some non-stoichiometric compound whose elemental composition can vary from sample to sample within a certain range. So for those compounds, the law of constant composition does not hold good. For them, the law of multiple proportion holds good, and we will talk about the law of multiple proportion in our next video. This is all about today's discussion.